In this demo, we are going to look at the test web application. We'll set up a DR for it between two OKE clusters. Both Oracle OKE clusters are running as part of same account, but in different regions. The production cluster is running in US West, while DR cluster is running in Germany Central. Both are using same versions, but Swift supports cross-cloud, cross-platform, as well as cross-version replications for DR. Also, in this case, though they are both using OCI block storage, I'll show during demo that you can actually choose what kind of storage you want to use during the initial application. Now let's look at both the production and DR environments. So what you see here is Oracle OKE cluster for the production, which is running in US West, and we have DR cluster which is running in Germany. Now we are going to use test blogging web application. It's based on WordPress. And to show that, what I have done is I have deployed the Kubernetes native dashboard for both production and DR clusters. Let me log into that. This is a production cluster. So there is a namespace called Blogger app. And you can see it has running bunch of pods, deployments, replica sets. So basically, it has two parts. One is database, and one is the actual core application, which is serving web pages. And that's running as part of deployment, while DB is running as part of stateful set, and both are running their own pods. Also, it's running load balancer service for main application for WordPress, and then the DB is running as like a cluster IP-based service. It also has a bunch of config max and secrets along with two persistent volumes. And they're using OCI storage. Now let's look at the sample application. So I'll just connect to it. You can see it has a application blog there. It's a stage blog. Let me log into the admin interface. So and you see that like it has the blocks created, a couple of categories created. It has sample posts created. Now let's go to DR cluster dashboard, and now in this dashboard I created same namespace just to show that it has nothing running. It has bunch of default secrets created. Those are primarily for the Swift. This captures the credentials of the image registry where our try image, which is our transient pod image, is located, because Swift will orchestrate that image pod using this secret. And I'll show like how you create that. Now, since we looked at the primary and DR cluster and the application, now let's look at how you launch this DR as a service subscription. So this is Oracle Marketplace. If you search for Swift and say Kubernetes, you should see our listings. Now there are three listings. So you have migration subscription, DR subscription. For today's demo, we will use the DR subscription. And you can see that it's an hourly charged OCPU-based subscription, and it allows you to do 10 unique apps or microservices per hour per OCPU. You can increase or decrease by adding more OCPUs to the Swift appliance. And you can essentially set up DR between any of them. Now we'll launch this. Let's click on Get App. So this will redirect you to the OCI Cloud account. We're going to launch it in a DR region of the OCI account, which will be Germany, Frankfurt, because that's our DR cluster is running. Because if you lose source region, you don't want to lose Swift. So Swift can be either in DR region or in some third region where it can access both source and DR clusters. So I'm gonna just launch the instance. You can look at the other details. So I'll just call it SWIFT DR instance, DRAAS. Change shape, it's Intel based CPU. And now I'm gonna pick this, which will, since it has two OCPUs, it will allow you like a 20 applications or 20 microservices for replication per hour, 20 unique microservices. I'll upload keys here. And the rest you can keep all the defaults. Okay, now Swift is running. Now let's add a block volume where it will store all the backups while Swift VM is getting ready. Let's do that. So I'll go to block volumes and create a volume named Swift backups. And let's now this storage size need to be same as the application source application data. If it's a 1 TB, you'll add 1 TB volumes. You can do multiple volumes. Essentially, Swift will club these block volumes into one storage pool. It's a logical pool. You can create more than one pools too. But for this case, since there is not lot of data, I'll choose 50 GB as the size. You can also pick the backup of this backup volume, which will give you additional security at the cloud level. But for this, I don't need it, so I'll just create it. I'll go back to instances where Swift is running. Okay, it's up. Now I'm gonna attach the volume, and what we'll do then is I'll select the volume. Swift backup is listed. Okay, and it's a read write. That's it. Okay, so it's attached now. Now to connect to Swift, you have starting up steps here. Let me go back. If you scroll down on this listing, there is a link here on how to connect to the Swift dashboard. There are two things you have to do. So first is you will log in with SSH to the Swift instance or Swift VM, and you will run this command to set the initial password. And you log in with admin, and then that password you set to the dashboard. And second step is taking the try image, which is our transient image used for running a pod on both sides of clusters. You have to upload this image to the respective image registry of that cluster, and so that way, and you also create one secret. It's called image pool secret in Kubernetes. So this secret is what you will tell to Swift that okay, here's the namespace in Kubernetes, here's the secret located. Use this to pull the image and run a pod. So essentially, you create this secret and register this secret in every namespace you want to replicate from Kubernetes or OK cluster. You can look at these examples, and it also gives you how to find the Swift input from the details. Now for this example case, we are using OCIR registry, and let me show you that. If you look at the container registry, and I actually have that running in US West. So it's essentially shared registry between two, because in today's demo we are not really replicating registries or setting up DR between them, but you can do that. Essentially, the registry which you use, that's what will be used for the replication. So I have uploaded image here, and steps to upload the image are here, and this is one time step, and soon this will be automated, but this is a fairly easy step. So let's get back to the instance. This is ready. So let's connect to this. Now let's start connecting to SWIFT dashboard. And again, so what I have done meantime is that I completed these steps here. I connected to the instance and then set up my initial credentials using this command. So I'm gonna just log in with that. Okay, there you go. Okay, so now nothing is running obviously here, and so it will drop us on the cluster administration page because there is no cluster added right now. So let's add our production and DR clusters. So let's call it OK production because that's what our first cluster we are adding. It's Oracle cluster. It's a production demo, and you can actually look at clusters here. This is our DR cluster. Let's look at the primary cluster. So you can see it's a OK production demo, and then we have OK DR demo. So we'll give the compartment and other IDs needed for this. It's located in the US West region. Yes, Phoenix region. And that's what we need. So there are a bunch of other things you can actually configure here, like when we run our transient pod, like what resources you want to use. You can always configure them later as well. While it adds it, let me show you something else. You can also go to the help and download documentation. It's very thorough documentation. You should be able to use that. Okay, so the cluster is discovered now. You can see that it has discovered all the details. Let's add the DR cluster too. Let's call it OKDR. Again, this is Oracle cluster. So OKDR demo, the details would remain same because located in the same compartment, just different region. It's the Germany, Frankfurt. Okay. Cluster ID is optional and add. Okay, so the both clusters are added. Now, as part of this namespace, I already uploaded our transient agent image into the registry used by this cluster. And I created a secret called OCPU credentials, which points to that image. Swift will look for this credential, like whatever you specify. You have to specify this here, and you can configure default for it. I'm just going to configure that. And what that does is that it will tell Swift where the transient container image is located for orchestration. It will pull image from there. So I'm gonna specify the image name and OCIR credentials. Just double check once. Yes, it's OCIR credentials. And that's it. We'll configure it. Let's configure the production as well as DR both clusters. Now you can actually specify this for each synchronization, or you can configure defaults. So I'm just configuring defaults, so that way it's going to pull that from the same registry. Now both clusters are using same registry, but ideally you will have a different registry. And you can set up DR policy for your container images too. Along with application, you can choose which images and versions and tag you want to sync. But I'm not going to show the image registry syncs as part of this demo. We'll publish shortly a separate blocks for those. Okay, now we configured cluster. Let's go ahead and add the storage where the backups will be stored. There's no backup added. We added a separate disk for that, so we'll use that. We'll call it Blogger app pool. And you can create more than one storage pool. This is just a logical grouping, and this allows you to create backups in different on different days, because you can combine days, different days. And now, right now, you have ZFS, but you don't need to worry about how it's managed. So this is Swift internal details. The reason it's there as a dropdown is because soon you'll have a cloud object storage option available here, so you can push your longer term backups in the cloud object storage. So SDB, as you can see, it doesn't contain any file system. You can always connect to the instance and verify this is the right disk and add it. And I'll make a default, the first pool is always default. And the advantage is it's always gonna pick that pool whenever you try to do any synchronizations. Now we are done with all the prep. So it took just few minutes, and now we'll start replication. Now typically you can directly set up a DR policy and start replications, but what I'm gonna do, and which we generally recommend, is that you first do synchronization, explicitly start a replication for your required application, verify that everything is okay, because sync has a lot of configuration options. You can verify those, and once you're okay, once sync works, then you can convert it into recurring sync by using a DR policy. So let's start synchronization. So we'll first back up source production application, which is our blogging app, to the storage we just configured as part of storage pool. So we'll select our production cluster. We'll select that, okay, we want to use the storage pool. Now there is no backup already here. Well, I'll call it blogger backup. So this is going to capture a bunch of volumes here along with the application objects. So this is just a logical name. You can create more than one backup, and you don't see right now, but the settings will be there as part of DR policy. You can create a backup policy, like at what frequency you want to backup. It can overwrite the existing backup. The first time sync is going to be full sync. The subsequent syncs will only transfer what changed. It will overwrite whatever changed. So in our case, let's go to the application. It's running as a Blogger app, and it has two microservices. Now, here's something interesting. You can select what applications you want to replicate. Like for example, I'll select Blogger app, and you can select like what applications you want. Let's say you only want one microservice replicated for whatever reason. So you can select that. Swift is going to intelligently find what that microservice is using. Is there a pod running where it's pointing? Who is running that pod? Like for example, a deployment, and then all the volumes used by that, all the secrets, config max. It will find that dependency intelligently and back up all of that. So you should be able to do that. For simplicity, I'm just gonna back up the entire namespace. So it will back up all the microservices, all the volumes, objects, secrets, config maps, everything. Now this option try is transient RackWare agent image. So this is a transient pod which Swift is going to orchestrate on both sides of cluster whenever sync runs. And you can select, it will also run a microservice, and you can select what kind of microservice it runs. So I'm going to select load balancer because Swift is sitting in the DR and it doesn't have direct access to the production outside of the public IPs. There is no special connectivity, and this is okay because all Swift traffic, whether it's from stage one or it's whether whenever it pushes data to your DR cluster, everything is encrypted. We use VPN grade encryption. Now you can let it select two ports from the service port range of the cluster, which it will use for sync apart from the API port. But in my case, I don't have those whitelisted in between a firewall, like the firewall we're running between Swift and like a production. That is OCI firewall. So I'm gonna give it two ports. So what's gonna happen is it's going to open these ports for us in the OCI firewall. But if there is any other firewall apart from OCI in between Swift and your cluster, then you have to, whatever ports you select, you have to make sure like you open those in the those all intermediate firewalls. It already picked the image, but you can always override here. You can also do dry run. It's going to show you like how much data will be transferred, what all will be transferred, but it's not going to actually transfer anything. And I'll call it initial stage one. So these jobs is just a friendly name. If you don't give it, will use name on soul, auto generated. This is useful because you can use this latter to convert into DR policy. So I'm gonna start it now. So sync is running now. It will rediscover the cluster and we'll see bunch of checkpoints. We'll also see once sync completes, we'll see how many objects it's backed up, how many volumes and data it backed up, and sync progress comes here. If something fails, you'll also see a lot of detailed checkpoints here. Right now it's taking backup of the volumes it found. So it found it using 2 volumes. So it's taking backup of those. As you can see now, it found 2 volumes and it will show progress nicely here as it syncs those volumes. In source, you can see it started our microservice. Let me refresh this. You can see it has started one microservice and it's pointing to a pod. So under pods also you'll see one transient pod running, and this will use our that transient agent image which we pointed to it. And same time the source application is fully up. There is no issue here. Sync finish, so you can look at like detailed statistics like how many volumes it transferred, how much volume data it transferred. So like this is backed up in the SWIFT storage now. Let's look at that storage as well. Let's go to our storage pool which we created earlier. We use that, so you can see like how much data is used here. So you see some data uses. Of course, this application is small, so no, not much data uses. Also, another thing to keep in mind is Swift will use compression. So typically we see almost anywhere between 30 to 40% compression. So as you capture more data, generally we see more compression. You can also see it has captured the image group, which is the actual application backup from the sync run. It has 2 volumes, so it has like 2 images captured, 2 volume images. This is the full replication. So now we'll change some data and do delta sync as part of DR policy. Before that, let's do stage 2 sync. So let's go back. We'll start new replication. Now instead of this, we'll select stage 2. So since there is only one pool, of course, it's going to show that. We'll select the image. Then now we select DR cluster. This is the namespace you want to select. Now here you will get all the storage classes which it found in the target or DR cluster. So you can change here like what your storage type. This is where you will also break the storage vendor lock-in from your production, especially if your production is running say on-prem and you are setting up DR with OK. I'll just select the region. This is where volumes will be placed. And again, I'll select the load balancer for the transient RackWare service. Just select 2 ports. And I'll call it initial stage 2. Let's start. So it started, created volumes and started synchronizing those volumes. Now in this sync, it's going to replicate the full volume. And if we run same sync again, stage 1 followed by stage 2, so only going to transfer delta amount of changes, like whatever data change, it will transfer those. Also, whatever objects change, it will transfer those. Also, as part of the stage 2, it's gonna replicate everything. Like it's going to create all the objects and all. So we should see those in the DR cluster. So it's right now running transient pod and service from RackWare. But you can see already the volumes are replicated here. Secrets and everything else should shortly pop up. We started replicating all the objects, so we should see those coming up here. It's also going to verify the health of applications once it's replicated. It will also do all the reconfigs, whatever you specify, like changing service types, for example. We didn't look at that, but you can do that as part of sync administration. You can configure those. And typically, let me just show those options. You can specify pre and post configs. You can specify what resources you want to use for our transient pod. You can also specify registry mappings in case your image registry endpoint changes between your production and DR clusters. You can specify that it will do that change for all the pods or containers. Similarly, you can change the service types, and you can also specify volume for exclusion. In case, say, you have some DB native synchronization in place, you can exclude those volumes. So it can still replicate everything else. Let's create a DR policy now. You go to the business continuity and DR menu. Go to DR policies. We don't have any. Let's create stage 1 to policy. You can also create stage 1 only policy, only backs up, Swift only backs up like application and data to its storage. And you can explicitly move this whenever failover happens, which will also provision the cluster and then restore everything. Now the provisioning cluster is not yet available. It should be available shortly. Let's create stage 1 to policy. Now stage 1 is going to back up from your source cluster to Swift, storage in Swift, and stage 2 is going to restore that backup to the DR cluster to keep it hydrated. You have a lot of options. Let's do by frequency. Let's say every 15 minutes we want to do it. You can also have like an exclude window. Now stage 2 can run with its own frequency, but I'm just gonna select run right after stage 1 every time stage 1 runs. I'll also specify my email for alerts. You can opt for like alert only on failure, or you can give it like let's call it 15-minute policy. Okay, so the policy is created. It's not applied. Let's apply it now. Now you can specify the configurations while applying the policy, but since we already ran syncs, now we can actually use those configurations from those replications, which is the easiest thing to do. Press apply. So the policy is applied. It's immediately going to start syncs. You can see that you can look at the history as well. Now you can see it immediately started sync, and then onwards it will run every 15 minutes. You can specify basically the start time. We choose to start immediately. Now you can look at the sync jobs here under active replications. You can see them. So it's running. Now keep in mind the DR setup we just did is part of the DR subscription Swift. So we just started Swift and started replicating and setting up DR policies. So that's how easy it is. So it's going to take down the target application because it will reconfigure everything. And that will happen as part of the stage 2 sync. So it completed stage 1, it started stage 2 as part of that sync run because we asked it to do back-to-back stage 1 and stage 2 syncs. And since we asked it to send alert for every sync, not just for failures, so it sent this alert. So this is how it looks. It will send you all the relevant details. Well, stage 2 is running now. So you'll see like everything is taken down. It's only our pod and services running. But volumes are still around, which is what it's syncing. It will recreate everything in terms of Kubernetes objects. Also for objects, you will see that all the labels, everything is retained. So sync is about to finish. We already see applications being restored, application objects, and you can see everything is restored correctly, and data will now be delta synced. So we should see our new page up. Okay, sync is about to finish. Everything is restored. Let's look at the application now. You can already see our new page is up. You can also try connecting to admin interface and we should be able to use that. You can see the new post is already up. So stage 2 finished. Let's look at some replications. So policy did a bunch of replications as part of this recording. Now what I have done is I have paused the policy to demonstrate something specific what you can do with policies. Now before that, let's look at the event history. You can look at all the sync history and how it is done. So anytime you can resume policy as well. It will also show you nice stats of like what the average sync time you are getting. Now, let's assume that failover event happens or the DR event happens on source side and you need failover now. So you can actually initiate that from the policy. Now you can failover all operations or specific operations. So we have applied policy only for one cluster pair. You can have more than one clusters. You may have more than one syncs applied under the same policy. You can select those. You can do drill failover. This is not just gonna do test failover. This is useful for testing. Also, the second option for stage 2. So what this will do is like let's say assume there is a stage 1 which happened. Now before it could push that stage 2, like the your source like went down, then it can force that stage to sync. So there is no outstanding stage 1. Uh, so whenever you fail over, if there is a stage 1 which has happened, it will fail over with that by completing stage 2 syncs. But if there is no stage 1 pending, it will just simply fail over with just state change. And that's helpful for testing too. Let's do the real failover. So we'll see that it's going to do one stage 2 syncs because I purposefully paused policy after it completed one stage 1 sync, but before it could do stage 2 sync. That's just to simulate the scenario where you have stage 1 happening more frequently and stage 2 is happening less frequently. So whenever you fail over, it's going to look at if there are any changes which are backed up but not yet restored on target. It's going to restore that one last time. So it's going to complete this syncs and then we'll see the application again coming up on the target cluster. Again, it will take down all the objects. So it has our transient pod running. And once it completes, the application will come back up again with all the data it has backed up. So that's what we wanted to show in today's demo. So we looked at how you can go to the marketplace, launch Swift, uh, migration and DR subscription from here, how you can use DR as a service. Then we deployed Swift. We did initial replication for OK application, and then we converted that into DR policy. We also did a test failover, and that all shows like how easy it is to do all these kind of DR setups within minutes. And all this we did in just matter of around 30 minutes.